Welcome back, Wolfpack, to 5.4 angle relationships. Let's go ahead and get started. One thing I want to remind you of is that angles are measured in degrees and their arcs are measured in degrees as well. So angle 1, however many degrees it is, AB is also measured in degrees. So an angle is measured in degrees and arcs are measured in degrees. I want to remind you of that. So the intersecting chords angle measure theorem says if two secants or two chords intersect in the interior, meaning the inside of a circle, then the measure of each angle formed is half the sum of the measures of its intersected arcs. So for example, the measure of angle 1, let me back up, chords AD and BC intersect at E. They're chords, they're intersecting. I think it's pretty clear to see. The measure of angle 1, this angle right here, it's going to be half the measure of AB plus CD. So whatever AB plus CD add up to, divide that in half, that's the measure of angle 1. And obviously, it's congruent to this angle because the vertical angle, so that angle would be the same as well. So let's practice one. Angle X is half of 43 plus 33, the two arcs that are formed. X equals 1/2 of 76. X equals, what is 1/2 of 76, or 76 divided by 2? X is 38 degrees. So that angle is 38 degrees. We will do example B together in class, but again, if two chords intersect, the measure of the angle is equal to half of the sum of the intersected arcs. The tangent secant exterior angle measure theorem says, if a tangent and a secant, two tangents or two secants, intersect outside of the circle in the exterior of a circle, then the measure of the angle formed is half of the difference, that means subtraction, difference of the measure of its intersected arcs. And we're only going to do one of these problems together because I want to do the majority of them in class. So, for example, the measure of angle 1, right here, that measure, that angle, let me draw it as an angle, that angle is 1/2 of AD minus BD. So I subtract AD and BD, cut them in half. The measure of angle 2 would be from EHG minus EG, cut it in half. The measure of angle 3 would be JN minus KM, cut it in half. Okay, so the first example is an example of a secant and a tangent. Okay, here's my secant, here's my tangent. Example number 2 is a tangent and a tangent. Okay, it's not going through the circle, it's intersecting at one point. And example 3 is a secant and a secant. Okay, so we will do one together and we will do the rest in class together. So let me scroll this down. The angle, which we know is 25 degrees, is 1/2 of the larger arc minus the smaller arc. Notice we're not actually finding the angle, we're finding an arc this time. So the first thing you want to do is get rid of that fraction. So I'm going to multiply both sides by 2 to knock out 1/2. So I have 50 equals 83 minus x. Well, we want to get x all by itself, so I'm going to subtract 83 from both sides. I have negative 33 equals negative x. And I don't need a negative x, I need a positive x. So I'm going to divide both sides by -1, both sides by -1, x equals 33 degrees. So the measure of that arc is 33 degrees. Okay, we basically do the same thing for the next two problems, but I will do those in class together. Just want to kind of go over this again. Let me erase this portion. Getting comfortable with the two different types of lines. A secant goes through a circle 2 times, so we have a secant, 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 and a tangent crosses out one spot. One spot, one spot, one spot. But the process is the same no matter what. Okay. The measure the intersected arcs, the difference of them, cut in half. If you have any questions, please write it down in your notes. We will do the rest of these problems in class together, as well as a graphic organizer that kind of summarizes all of these theorems. Hope you're having a great day, Wolfpack, and I will see you next class.